Today, I'm going to show you how to turn your smartphone into a digital microscope. All you need is a smartphone, a few tools, the focus lens from a cheap laser pointer, and about $10 worth of materials from the hardware store. Not only will this homemade microscopy stand allow you to take high-quality macro photos, but with the ability to magnify objects up to 175 times, you can see and photograph cells. At these levels of magnification, plant cells are easy to see. This rig can even be used for rudimentary laboratory experiments. We were able to observe plasmolysis in red onion epithelial cells. As you can see in these time-lapse photos taken with an iPhone, the cytoplasm pulls away from the cell wall when exposed to a saline solution. You're not restricted to a laboratory setting with this microscope. It was designed to be easy to operate, lightweight, and portable. All you need to do is align your smartphone's camera with the focus lens on the top of the stage. Place the object you'd like to view on the adjustable specimen stage. From here, bring the object into focus by slowly turning the wing nuts on either side. Once it's in focus, you can take a picture, or video, or even zoom in for a closer look. Switching samples can be made easier with the use of a small plexiglass slide. Because the stages are also constructed with plexiglass, objects can easily be viewed without the use of an external light source. This allows the microscope to be used in a wide range of settings. Whether it's in the classroom, outside, or in your own home, this simple setup will allow you to take a closer look at the world around you. It only takes about $10 worth of materials and 20 minutes of your time to build this microscope stand. You will need a cheap laser pointer, some 1/8" plexiglass, plywood, a few nuts, bolts, and washers. A small LED light is also useful for backlighting cell samples. The only tools you will need are a drill and a few assorted bits. Pliers might come in handy too. First, you will need to remove the focus lens from the laser pointer. Start by unscrewing the housing and removing the batteries. The focus lens is right behind the nose cone. Using the back end of a pencil, push the inner assembly out of the front of the housing. Unscrewing the plastic cap on the front of this assembly should free the lens. Make a mark with a Sharpie on the front two corners of the plywood base, 3/4 of an inch from both sides and the front edges. Make another mark, centered on the board 3/4 of an inch from the bottom. Stack the plexiglass camera stage on top of the plywood. Be sure to line up the edges. Offset the specimen stage so that it extends 3/4 of an inch off the front of the base. When they're all lined up, drill through the pieces. In order for the microscope to sit flat, you will need to countersink the bolt holes underneath the base. After inserting the bolts, flip the base over and add washers and nuts to secure the bolts to the base. Next, drill a hole the same diameter as the lens, in line with the front two bolts. To make sure the LED light is centered below the lens, use the hole you just drilled to mark the position of the light. Be sure not to drill all the way through the base. Embed the lens in the camera stage by gently pressing it into the hole. Now you're ready to assemble. Add the wing nuts and washers to the front two bolts. Next, add the specimen stage. Add a nut to each bolt and then place the camera stage on top. Before securing the stage in place, check to make sure it's level. Tighten the final 3 wing nuts, add the LED light, and your microscope stand is now complete. I'm a major proponent of making home science more accessible. My goal in designing and building this phone to microscope conversion stand is to provide an alternative to overly expensive microscopes. This setup is a viable option for underfunded science classrooms that would not otherwise be able to perform experiments requiring a microscope. But more than that, this device will allow people to rediscover the world around them. For more information on the assembly and use of this project, please visit the Instructable linked in the comments below. Thanks for watching, and stay curious.